This lesson is about expanding binomials to a power using the binomial theorem in Pascal's triangle. So what we want to do is look for what the patterns are in taking a binomial to a power. So if we were to multiply this out, you would get the identity x squared plus 2xy plus y squared. If you were to take x plus y cubed, which is x plus y times x plus y times x plus y, and multiply it out, you would get x cubed plus 3x squared y plus 3xy squared, and then plus y cubed. And then if you were to take x plus y to the fourth, which would be that x plus y multiplied 4 times, multiplying that one out, you would get x to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth. So those expansions help us see a pattern developing, and that pattern is what's called Pascal's triangle, especially if you think of this as above this having x plus y, and then maybe just an x up here. Looking at just the coefficients, forget about the variables, but just the coefficients. Notice that the coefficient here is a 1. Coefficient here is a 1 and a 1. Here I've got 1, 2, and 1. Here I've got 1, 3, 3, and 1. And here my expansion is 1, 4, 6, 4, and 1 of the coefficients. Now maybe you can see the pattern coming that you have 1s along each of the sides, but after that, if you take each of the two numbers and add them and fill the gap with this, the sum of those, I get 1 plus 2 gives me the 3, 3 plus 3 gives me the 6. You can get the next row without having to multiply it out by recognizing, for instance, the fifth row would be with a 1 and a 1 here. 1 plus 4 gives me a 5, 4 plus 6 gives me a 10, 6 plus 4 gives me a 10, 4 plus 1 gives me a 5, and I've got the expansion for a fifth power on this. So if I was interested in doing x plus y to the sixth power, instead of having to multiply it out, x plus y 6 times, which would take quite a bit of time, Pascal's triangle tells us if we fill in this next row, 1 and 1, and we add these two, we get a sixth power. This is 15. 10 and 10 would give me 20. 10 plus 5 would give me 15. And then 5 plus 1 would give me 6. I have the coefficients of the expansion of that to the sixth power. Now let me write out those coefficients here. So I'm going to write 1 plus 6 plus 15 plus 20 plus another 15 plus 6 and then plus 1. Now, how do you fill in the x's and y's is the next question. Well, if you notice the pattern here, the x's start at the exponent here and then they go down in powers, 4, 3, 2, 1, and then none. Whereas the y's start out with none of them here, and then they go up in powers, 1, 2, 3, and 4. So here what I'll start with is x to the sixth power on the first one, no y's, and then I'll just have the x's go down in powers, x to the fifth, x to the fourth, x to the third, x squared, and then x, and then no more x's on that one. And then I have the y's start, no y's, and then a y to the first, y squared, y to the third, y to the fourth, y to the fifth, and lastly y to the sixth. So you expand it out by decreasing the first one and increasing the second. That gives us a pattern that we can use for the binomial theorem. Binomial theorem tells us to use the coefficients from Pascal's triangle, then the first term decreases in power, and the second term increases in power. Let's see how that works out with expanding a few binomials that are a little bit different. So here, if I want to use this one here, x plus 4 to the 5th power, I go to the one with the 5 in the row. So I'm going to write out the coefficients there. So I'm going to list the 1, 5, 10. 1 plus 5 plus 10. And I'm going to have a 10, 5, and 1. 10, and a 5, and then a 1. And now I need to take each of these on the inside, have this one start out and decrease, and this one start out at 0 and increase. So I'm going to start with x to the 5th, x to the 4th, x to the 3rd, x squared, x, and then no more x's. And now start with the 4, put 4 to the, this first one we don't have any, so it is left without any 4s. And so this one we have a 4 to the 1st, times 4 squared, times 4 to the 3rd, times 4 to the 4th, and then times 4 to the 5th. And now I can just simplify each of those terms. Okay, so I have an x to the 5th here, plus, and now I'm going to do 5 times 4. That just gives me the 20 with the x to the 4th. Here I'm going to do 10 times 4 squared. 4 squared is equal to 16, times 10 is 160, x cubed. This is 4 cubed is equal to 64. 64 times 10 is 640, x squared. 4 to the 4th power, that's equal to, let's see, 4 to the 4th would be 256. 256 times 5 would give me 1280. And that just has an x there. And then lastly, 4 to the 5th power is 1024. With no x's left there. So that's how we use the Pascal's triangle to get the coefficients. And the binomial theorem tells us that the x's start out at the 5th power and then decrease. The 4 start out not showing up and then increasing in power. Let's do one more example here. Let's do 3m minus 2 to the 4th power. Okay, so on this one, we're going to use the 4th row of Pascal's triangle. And so that 4th row is a 1, and it's a 4, and it has a 6, and it has another 4, and it has, ends with a 1. I'm going to start off with the 3m being to the 4th power, so 3m to the 4th. I'm going to do 3m to the 3rd, and 3m to the 2nd, and 3m to the 1st, and then no more out of this first term. And then we're going to take the -2, notice that it does have a negative, so I'm going to have it blank in the first one, then -2 to the 1st, and -2 squared, and then -2 cubed, and then -2 to the 4th power. And now I just have to simplify those coefficients. Okay, so for this one, I'm going to have, and I need to make a slight correction here on this one. Notice that I put the 4th power inside here. It needs to be the 4th power is outside here, because that's important to recognize that the 4th power goes to the 3 and to the m. So 3 to the 4th is equal to 81, m to the 4th. This one's going to be 3 cubed, which is 27, times 4 times -2, and that's going to be a negative because we have a -2 there. So subtracting, when I multiply those, I get 216, m to the 3rd. And then I got 6 times 3 squared, which is 6 times 9, times -2 squared, which is another 4. So it's going to end up being addition because the square of a negative will turn into a positive. That's 216 as well. M squared for that term. And then we're going to do here 4 times 3 times negative 2 cubed. The negative 2 cubed is negative 8 times 3 times 4. That gives me negative 96m. And then lastly, we're going to do negative 2 to the 4th power, which ends up being 16. So to expand these out, just use the 3 steps. Use Pascal's triangle to get the coefficients. Put the first term to the exponent and then decrease it. And then put the second term, leave it blank the first time, and then increase it after that, and then simplify the result.